All right, continuing on. So taking the derivative, you know that the derivative of cotangent is negative cosecant squared. Carry the angle along, even though it's a trig function, a little bit different, and then take the derivative of the inside. Here, to take the derivative, I'm going to bring the 1/2 down to the negative 1/2 power, carry the inside along, and then take the derivative of the inside, which is secant squared. Here we go, derivative here. Derivative of cosecant is negative cosecant cotangent. Again, I'm just leaving space to carry the angle along, and then I multiply by the derivative of e to the x, just one of them, and that's it. I'm going to take the time to rewrite this one. This is x to the 3/2, right, because it's power over root. So the derivative will be negative cosecant squared, carry the angle along, and then multiply by the derivative, and there it is. Okay, so we know the derivative of e to the x is just e to the x. So here we have e to the stuff. So the derivative of e to the stuff is e to the stuff times the derivative of stuff. So here we go. So the derivative here, derivative of e to the cotangent, I just write down e to the cotangent, and then I multiply by the derivative of cotangent, which is negative cosecant squared. This one here, I want to be really careful. I want to make a big note about it, because there's many mistakes that happen with this. So let's talk about 1 over x. 1 over x can be rewritten as x to the negative 1 power, right? So I'm just going to rewrite this, e to the x to the negative 1 power. So to take the derivative of e to the stuff is e to the stuff. And then let's talk about how do we take the derivative of x to the negative 1. That's negative x to the negative 2. So I could rewrite this as negative 1 over x squared, right? So it doesn't matter which way you write it. I just want to make sure you take the derivative of that correctly. Okay, here we go. So this is, now we have a derivative of a to the x. So derivative of a to the x, so that means any other number other than just the e. This rule does work for e. So if I think about it, if I've got, get my pen working here, if I've got f of x is equal to e to the x, this says the derivative is e to the x times ln of e. Oh, and ln of e, you know, is 1. So the rule does work. So if this is the derivative, or this is the function, the derivative is 2 to the x times ln of 2. Okay, so let's do some more interesting one. A to the stuff. It's a to the stuff times ln of a times g prime of stuff. So doing this example, the derivative would be 3 to the stuff ln of 3. Notice it's always ln of the number, and then the derivative of sign, which is cosine.